Today we're going to talk about simplifying the general balance equation. And so before we go anywhere, I just want to state that there are two types of balances that we can write that will help us when we do the general balance equation. So one is differential, and this indicates what is happening at an instant in time. And this is typically what we're going to write in this class, is instantaneously what is happening in a certain amount of time. So each term in the balance is written as a rate, which is in units of quantity per time, and it's usually applied to a continuous process. So differential is real world, what we're going to be doing all the time as environmental engineers. And just as a reminder, right, differential is related to the slope of a function or the slope of a curve, right? So at an instant in time, this is what we're talking about. Now, we can also write what are called integral balances. And integral balances are what happen between two instances in time. So each term is an amount of the balanced quantity. We're going to see both of these this semester. These are usually applied on batch processes. So remember, an integral is the area under a curve under 2 points in time if time is the x-axis, which is normally is for us. So there's going to be two ways we look at this. Remember, differential is mostly continuous process, and batch process is an integral balance. And they're going to be written slightly differently as we go through problems, but we'll see an example of each. Okay, so we're going to go through some rules to simplify the mass balance. If we are balancing total mass in the system, we know that total mass, not mass of a specific compound, total mass, we can't generate or consume mass because this breaks the law of mass conservation. If we are creating total mass in the system or destroying total mass in the system, we've broken physics and the universe, right? So again, total mass, not mass of A, not mass of B, total mass in the entire system. If this is the case, the generation term right here can go to 0, and the consumption term can go to 0 in this particular case. This means that the input minus the output in this type of system is going to be accumulation. So number one thing you look at it in a problem, can you balance total mass? If you can balance total mass, you can simplify the general balance equation to something easier. Next one, if the balanced substance is what's called a non-reactive species, right? So it's not going under a chemical reaction. So if A is not going under chemical reaction, if B is not going under a chemical reaction, that is a non-reactive species. If that is the case, because you are not creating any more A, generation goes to 0. And because you are not consuming any extra amount of B, that means consumption also goes to 0. So we get down to the same simplified balance where we say input minus output is equal to accumulation in a system. Last key rule here, if the system is in steady state, we know we are not accumulating any mass in the system. So we can set accumulation equal to 0. This means that the input plus the generation minus the output minus the consumption must be equal to 0. So if we rearrange so all of our terms are positive, that means the input plus the generation equals the output plus the consumption. Okay, so these are some ways that we can start to simplify the mass balance. There's going to be a couple more that we're going to learn as we go throughout the semester. And you can combine all three of these rules, right? So you could get something like input equals output, and that's a really easy equation to solve. So make sure you understand these rules before you head out of this particular pre-lecture. Canceling out terms in the general balance equation is really going to help you solve your mass balance problems.